Welcome to Hubble's Universe Unfiltered. The year 2015 was the 25th anniversary of the launch of the Hubble Space Telescope. And every year for the anniversary, we produce a special image to celebrate. Now, it's kind of hard, after all the amazing images that Hubble has produced, to find one image that's more spectacular than all the others. However, for the 25th anniversary, we wanted to do something special, so we made it stand out in a different way. Let me orient you toward the target. This video starts in the Carina constellation, which features the wonderful Carina Nebula that Hubble has looked at many times, but that's not the target. There are several smaller nebulae to its right, and this nebula is the target. It's called GUM-29. This is a ground-based image of the nebula GUM-29, and you can see it consists of a star cluster and its associated gas. The ultraviolet light from the stars is heating the gas and causing it to glow. However, if we look in infrared light, this is an image from the Spitzer Space Telescope, we can see that the gas is actually warmed over a much larger region than we see in visible light. We zoom in towards the center of the star cluster, and NASA's other great observatory, the Chandra X-ray telescope, took this image of the star cluster. And you can see the copious amounts of X-rays coming from that star cluster, which indicates these must be very massive stars. Getting a lot of X-rays indicates you've got a really massive star cluster here. So, looking at those images gave us optimism that this was going to be a really cool image from Hubble. So here is the field of view in the Spitzer image that Hubble viewed with visible light. And Hubble has much better resolution than Spitzer. So this was the release image of the nebula GUM-29 and the star cluster Westerlund 2 at its core. And the resolution is even better than I'm showing you here, because this image is about 9,000 pixels across. So if I zoom into that star cluster, you can see it breaks up into an amazing number of stars. There are several thousand massive bright stars in this cluster. If I look along the nebula wall, we see a whole range of these pillars. We've seen lots of pillars with Hubble. Well, here we have several of them all in one region along the wall of the nebula of GUM-29. We also have one of these pillars bathed in sort of this purple glow. And so there's a lot of cool details in this image. And Hubble was able to get a really wonderfully high resolution and all sorts of interesting details. Now, to make it special, I work in the visualization group, and they asked us to take this 2D image and pull it out into 3D. To remind you that these aren't 2D picture postcards of the night sky, they're really representations of a three-dimensional universe. Well, to do that visualization, we recognized that this press release image was actually part of a slightly larger region. This was the full image that we took with Hubble, and we cropped down to that for the press release image. And we're going to take that full image and place it on top of the ground-based image to give you context. Now, when we do a visualization, we want a widescreen aspect ratio. So we cropped it down to the widescreen aspect ratio. We blended the Hubble image and the background image together, and this was our starting point for our visualization. Now, we want to take a look at that nebula, but you've got all these stars in the way. So the first thing we do is, boom, get rid of all the stars. Now, I love giving talks and being able to go one slide to the next and having all those stars disappear. But of course, you should recognize that's a tremendous amount of work by our visualization team. And of course, once we get rid of those stars, we have to bring them back in. For this, we developed a new technique of point spread function stars. Now, let me explain what that is. So, when Hubble observes a star, that star is just a point of light. And the brighter stars get bigger on Hubble's detectors, and they spread out. So we characterize very carefully how a point spreads out on Hubble's detectors. We call that the point spread function. We astronomers are pretty straightforward in what we call things. Here is an example of one of Hubble's point spread functions. So you can see in the upper left, it's just a dot. And as you come towards across and down, it gets brighter and brighter, and the star gets bigger and also develops these diffraction spikes. This is what a star looks like in one of Hubble's detectors as one gets brighter and brighter stars. Knowing that, we can go in and examine the Hubble image and characterize those stars. So we did it in 3 different filters, one that will be red, one that will be green, and one that will be blue. We measured the positions of all those stars and their brightnesses in the 3 different filters, and then using the point spread function, we could recreate those stars artificially. Well, I don't want to say artificially, more synthetically. We can create them digitally without going into the image and cutting out little postage stamps around each star. We could go in and create them digitally. Furthermore, you may notice that the stars of the cluster are significantly redder than the other stars. That helps us pull out the stars in the cluster and separate it from the stars in the foreground. We do that with what astronomers call a color-color diagram. And basically, it's just a way of separating which stars are redder or bluer than the others. And in the left-hand panel, you can see that white line, well, those are the foreground stars, and the red clump, well, those are the stars we identified as being part of the cluster. Here in the middle panel, we've got all the stars together with the cluster stars colored red, and in the right panel, we have the foreground stars. Using this color-color diagram enabled us to do a pretty good separation between the stars of the cluster and the stars in the foreground. You can see it wasn't a perfect separation. There's a little overdensity in the foreground stars, but for the purposes of this visualization, it's quite sufficient. So here are the stars of the cluster and the foreground stars, all created synthetically using point spread functions. Now you'll notice there are empty spaces on either side where we blend it into the ground-based image. To do that, we had to go to another catalog from the 2MASS survey, and we gathered stars from a wide region around this area, and then identified those that were in our field of view, but not inside the Hubble part of the image. This is an infrared catalog, so we had to take the band passes in infrared, map them to the Hubble band passes, and adjust the magnitudes appropriately to get the proper colors. Again, we used the Hubble PSF, and we ended up being able to fill in the stars on the outer part of the field. All together, here are all the stars done with this point spread function technique. Now we've got to deal with the nebula itself. And the nebula has several parts. You can see here's the foreground gas on the near side of the nebula. Here are all these pillars along the inner edge of the nebula. And then we've got that bright gas in the background part of the nebula. Each of those is going to be a separate layer inside the nebula. And we're going to do it with a technique we call sculpted decoupage. Let me explain a little bit. Here is an image called the Great Wave of Kanagawa, and it has several layers in it. You can see that you've got the wave in the foreground, you've got the mountains in the background. And if you take that image multiple times and slice it up into the various pieces, and you take those pieces and put them together with little separators in them, you can create what's called a decoupage box. Here is an actual decoupage box, and here are views of it from different angles showing how you get a 3D technique by simply putting in multiple layers of the same image. Well, we're going to do the same sort of thing digitally, but we're also not going to use just flat layers, we're going to sculpt each of those layers. So for example, these are the layers in our digital model that represent the background of the nebula. And you see how they have sort of a bowl shape because that's how the background part of the nebula would look. Here are the layers that represent the pillars, and you'll notice that one of them is tilted because we want to make sure all of those pillars point towards the star cluster, because it is the energetic radiation from the star cluster that is creating those pillars. All of those pillars point in 3D towards that star cluster. Here are the layers that are on the foreground of the nebula. And finally, we have a layer just in front of the nebula called the veil, which is a layer of thin gas that sort of forms a bubble along the front of the nebula. Add to that the cluster stars, as well as the foreground stars from Hubble, and then the foreground stars from the surrounding region. Together, you get the full 3D model that we use for our visualization. Looks kind of like a Christmas tree. Of course, this is a side view of it, and the camera would actually be located at the top of the tree. Here is a movie showing you a buildup from back to front. We start with the background layers of the nebula, the brighter gas, add in the cluster stars, and then all of those individual little pillars along the inner edge of the nebula. Then we start with several layers for the foreground, add in the veil layers, and finally add in the stars. Now we have ourselves a full three-dimensional model, and we can create the visualization. We called that visualization celestial fireworks, both for the large number of very bright stars in that cluster, as well as for the celebration of Hubble's 25th anniversary. I thought it was a fitting addition to an amazing panoply of Hubble's imagery. Thank you for watching. We'll see you next time on Hubble's Universe Unfiltered. We wanted to do something special, so we made it stand out in a different way. Let me orient you toward the target. This video starts in the Carina constellation, which features the wonderful Carina Nebula that Hubble has looked at many times, but that's not the target. There was the 25th anniversary of the launch of the Hubble Space Telescope. And every year for the anniversary, we produce a special image to celebrate. Now, it's kind of hard, after all the amazing images that Hubble has produced, to find one image that's more spectacular than all the others. However, for the 25th anniversary, we're using it to glow. However, if we look in infrared light, this is an image from the Spitzer Space Telescope, we can see that the gas is actually warmed over a much larger region than we see in visible light. We zoom in towards the center of the star cluster, and NASA's other great observatory, Welcome to Hubble's Universe Unfiltered. The year 2015, there are several smaller nebulae to its right, and this nebula is the target. It's called GUM-29. This is a ground-based image of the nebula GUM-29, and you can see it consists of a star cluster and its associated gas. The ultraviolet light from the stars is heating the gas and causing